Hello 108 class, Mr. McHugh here with you to kick off section 8.6. We are cruising through chapter 8. We're going to finally start solving some equations that have got radicals in them. Okay, and of course we're going to take care of page 1 here. And objective number 1 gives us a hint as how to do this. It says to solve radical equations. We could do that by squaring the radical equations on both, well, it doesn't say all this, both sides of the equations. We're going to square it. Okay, so here's the principle I'm trying to put here now. If I give you the square root of 6, let me back this up. This is what I do on the board. Here's the square root of 6, and this is just understanding what happens every time you take a radical and you square it. You have discovered that the radical will disappear. Okay, and instead of having numbers, we're going to have variables under here. And of course, you've seen this over and over again. Square root of 6 times the square root of 6 is 6 times 6 is 36. The square root of square root of 36 gives you 6. Okay, aka the radical is gone. Okay, so to start this process off, look at a very easy equation. It says something like the square root of x equals 3. Now our challenge is to isolate, just like we always have, the variable. But to isolate it, you've got this radical. And so now you've got to trigger into your toolbox. You're going to pull out your squaring tool. Square the left side and the right side of the equations. You still maintain balance, okay? And on the left side, the square root of x squared is going to drop the radicand, is going to drop down. You're going to hear me say this a lot. You drop the squaring, undoes the square root, and you drop the radicand down. And 3 squared is 9, and you got your answer. Okay, so that's the concept, except you're going to see some a little more tougher problems here to get going. But let's review the steps here. Number 1, isolate the square root on one side of the equation. Doesn't matter whether it's left or right. So you'll see some of these, you might have another term besides the square root with the variable, so you move it over and you isolate the radical. Now square both sides to remove the radical. Then work on your usual algebra toolbox properties and isolate the variable to solve it. And then here's the kicker. Now this is we need to check all proposed solutions in the original equations. Now this can be a little bit of a PIA, pain in the butt, because erroneous solutions are introduced when you square numbers. Now here's what they do. Here's this the example they give, for the informal proof for that. Start with the statement x equals 1. Now I worked sideways here, but square both sides of the equation. X squared equals 1. Oh my god, x squared equals 1 squared. I squared both sides. I probably should have went like this. Okay, now what's the result? X squared equals 1. Now what you didn't see me do on the board here now is you got to isolate the variable. Now go back and take the square root on both sides. Square root of x squared does produce x, but over here the square root of 1 could be either a plus or a minus. Negative 1 times negative 1 is also a positive 1. Thus, the unfortunate circumstance is we start with x equals a positive 1 and we introduce this erroneous negative 1 into the equation. Okay, so got to keep that in mind. Don't forget that. I tell my students, look, when you're doing homework, you've got my math lab. Will check your answer. It's going to help you with that. When you take your quizzes and tests, you got to remember to do it the old school way, like I did. Okay, so let's try example number 1. Ooh, what are we going to do? You look at this and they say the square root of the quantity 3x plus 4 equals 8. You go, and you go, what can I do? I don't care for radicals. Yes, square both sides. It's already isolated, so square it. Okay, once you do that big step, what drops down? The radicand drops down, 3x plus 4. Okay, squaring does the square root. 8 squared is 64. Now you're back into familiar territory. You're going to do what? Minus 4 on both sides. 3x equals 60. Isolate the x variable. You know the drill. Divide by 3. 60 divided by 3, and the answer is 20. Now step 4, here's the new one. Check your solutions. Okay, and I don't do this on the board, but showed it here. Take 20, plug it back into the equation. Does it work out? Put 20 back in for x. You do the dirty work and you can see that it does. Solution set is a 20. Okay, so hey, we got started not too bad here for page 1. We're going to do some more problems of the same type. They'll get a little tougher here, so we'll work our way through, but that's the high level concept. Okay, Mr. McHugh, going to sign off here. Page 1 done. and I will see you for page 2. Okay, take care. Bye.